So today was the first lesson in completing the square. There is a part 2 to it where you'll learn how to do it when A is not 1. Because there's always like a little bit of extra steps whenever A is not 1. But completing the square is one of like the 4 major ways to solve quadratics. And when we say solve, like solutions, we mean x-intercepts, we mean, what else do we call them? Solutions, x-intercepts, roots, and zeros. Good. So you've already learned how to solve in a bunch of different ways, but know that like the test will require you to know the procedures of each method. So if it says, find the error, and this person did it by completing the square, if all you're relying on is using Desmos to confirm what the zeros are, then you'll probably get that question wrong. Like you have to know the steps for them all. Like for example, on your test, and I know some of you haven't had the lesson yet, so it might not make sense yet, but on your test, it'll look kind of like our cool down from today. It'll say, given this problem, what needs to be added to both sides to complete the square? If you like haven't been practicing it, then you would have no clue what needs to be added to make it a perfect square and things like that. So completing the square is like a little bit of a weird series of steps, but they are entirely possible. So I think if you just follow the steps to the T, then it should be no problem. But, you know, sorry, trying to get there. If you have not had the lesson yet, and you might want to like take a picture of these steps for now, we can do an example. I'll do an example from the note sheet. But these are the steps. For completing the square, we want it written in this format. And this really only works when A is 1. It will be slightly different when A is not 1. But we want it written where it's just the x squared term and the x term on one side. Let me actually snip an example so we can have the steps right next to it as I go through it. So give me 1 second. If you already have the note sheet from this morning, it will be the last problem if you want to like write it down. It'll be this one. Okay. Okay, so here's an example that we'll solve using these steps. So first step is to rewrite it where we have the x squared and the x term on one side and the constant on the other side. Is it already written in that format? Whoever's blasting their music, like, for the love. I should just honestly take it away. I have made my other math lab turn in all their phones and headphones. Like, we could do that if that is what makes you work and listen. So I repeat, is this already rewritten in the form we need it to be in order to complete the square? Okay, so then we move on to step 2. If for some reason it wasn't, then you would do your inverse operations, like say they gave us this to start with. You would do your inverse operations to move just the constant over to the other side. So that this is now alone and the constant's on the other side, but that step's already done. So move on to the next step. It says to take half of B. What's my B value in this problem? -16, so I'm gonna take half of -16, what is that? -8, and then square it, what's -8 squared? And I know these are weird steps, you'll see in the activity today why it is those steps, but it says take half of B, square it, add it to both sides. So from my original problem, I'm going to add 64 to both sides. Why, you might ask? Well, it makes a perfect square trinomial on the left side. So notice these are not like terms, like you can't combine any of them, you just rewrite it as a trinomial. And it also makes a perfect square on the right side. But it's a rule that whatever you do to one side, you have to do to the other anyway. It just so happens to make a perfect square here too. What's negative 60 plus 64? Okay, so that's me doing step 2. This is what actually completes the square. This makes a perfect square trinomial, which makes it much easier to solve. Step 3 is to factor the perfect square trinomial. So that's where you would do like your diamond method, looking for two numbers that multiply to 64 but add to negative 16. What does that? Negative 8 and negative 8. It should be the same number because we're trying, the whole point of this was to make a perfect square trinomial so that we could write it in the condensed form like this. Now it's just one X that I'm solving for versus like these different ones where I couldn't really isolate them before. And now I can solve it like how we ended the lesson yesterday by taking the square root of both sides and solving for both cases. So basically isolating X. What's opposite of squaring? Whatever you do on one side. So then I get X minus 8 because that cancels out the square. What's the square root of 4? Plus or minus 2. So remember, we have to solve for both cases. Most of the time, there are two solutions to quadratics. So this is where the two solutions comes from. If from this step, you need to separate it into two problems, by all means. I like just working with the plus or minus. I think it makes it like more neat on my paper. But we're solving for when it's equal to the positive 2 or when it's equal to the negative 2. And still isolating the X. What's opposite of minusing 8? Whatever you do on one side. And that's what we'll end up doing over here too, by the way. So then we get X equals 2 plus 8, which is, so one of my answers is 10. And then X equals, what's negative 2 plus 8? My other answer is 6. So it's another method of solving. Yes, you can confirm your answers by checking that these are the x-intercepts for that quadratic. But on your test, it's not going to be that easy. Like, it's not just going to ask you what the answers are. It's going to say, where did this person make a mistake in completing the square? It'll say what number needs to be added to both sides. And you would say 64. Just things like that. So that's why I want you to please practice it with this method. The steps I'll leave right there. The practice today is lesson 12. You can ask for help as you go. You can ask for help on other practices. Some of you are so behind. I like question what you do every day in this class. You should do this, get 80% or higher on it, and then go back, get all your other stuff ready. There's just no time to like fix your grade at the end of the school year. You need to do everything as you go. Questions? No,
So number 2 on the lesson 12 practice, if anyone else had trouble with that one too, we are matching each equation to the equivalent equation with a perfect square on one side. So if you're wondering like what in the world they're wanting you to do, it would be this step in your completing the square step. So when you make the perfect square on one side, you would have already rewritten it, which it looks like all of these are in the format it wants it to be, except for maybe like this one. We'll have to rewrite that one. But then they want you to take half of b, square it, add it to both sides. I know it's a really weird step, but that's how you make a perfect square trinomial no matter what you have on the left side. So we're gonna take half of b for this one. What is b? So what is half of 8? And then what is 4 squared? 16. So that's what we would have to add to both sides. And whatever you do to one side, you have to do to the other. So make sure you do it to both sides because that's to keep it equal. And then on the left side, I'm looking for one that looks like that, but also it kind of looks like my answer options have them already even factoring that perfect square triangle. So we have to do that too. What I always notice is that when you go ahead and factor it, it always ends up being the number here. But you could just factor it like normal. So adding the 16 makes it x squared plus 8x plus 16. What multiplies to 16 that adds to 8? Yeah. 4 times 2. Okay, and that's what it should be. It should be like the same number making it. That's how you know that this step went well because it makes a perfect square trinomial on the left side of your equation. So then my left side becomes x plus 4 into x squared. My right side, after we added the 16, was 2 plus 16. 8. And let me just make sure that's one of the options. Yes. So to avoid like having to keep scrolling, I'm just gonna write the answers here to make it match up. And pay attention, yours could be shuffled. So don't just like blindly copy. Make sure you are matching it up appropriately. So then I also probably won't do all of these because I do want you to try it too yourself. But let's see like the next one. What is, it's already rewritten into this form. So that's good. We can go on to the next step where we take half of b, what's b? And what's half of it? 5. So we take half of b, we square it, what's 5 squared? And that's what we would add to both sides. So then my right side, the negative 13 plus 25, I want to say is 12. Please correct me if I'm wrong. Pretty sure. And then the left side, I mean, maybe you can find your answer even just from that. But you can. But the left side you get from factoring that perfect square trinomial, and what multiplies to 25 adds to 10, you get 5 and 5. So then rewritten in the condensed form, it's the x plus 5 in parentheses squared. Right, and then do the same with these others. Pay attention to the integers, like whatever this one is. I won't tell you the answer for that one, but it should be negative because it's adding to a negative. And things like that. This one down here, that's not rewritten in this form. How can I make it to where the constant is on the other side? How do I make the negative 5 cancel on the left side? And then whatever you do on one side. So like, you can't just like pick it up and move it. Like you have to cancel it on one side and then do the same to the other side. So then that makes the negative 5 cancel. I now have x squared plus 4x equals 5. And then you can continue on with the rest of the steps, where you take half of b. So what's b in this situation? Just the 4, so just the number. And what's half of 4? 2. And then we're gonna square it. What's 2 squared? 2. This is the number we have to add to both sides.
to make it, or let me put it over here, so it's not confusing. To make it a perfect square trinomial on one side. So then from that, I know my right side is 5 + 4, which is 9, that should probably narrow it down for your answers. But the left side, when you factor that trinomial, what multiplies to 4 and adds to 4? 2 and 2. So then this side, and because it has to be positive to do that, it's x + 2 in parentheses squared. Does that make sense? Okay, so I do want you to try the others that I didn't necessarily work out for you. And if you're still having trouble, we can revisit it, but now that I showed you 3 out of the 6, try the others to see if we're gonna do them. Other questions from any practice?
Confirm them, so let me just move the ones I already have. Okay. So then what does this one have to be? Or maybe not, let's go from the steps in the beginning. So is it already rewritten to where it is x squared plus bx equals c? This one? Does it already have the constant alone on one side? Yes, no? Okay, so then I don't need to worry about rewriting it. I can just go ahead and take half of b. What's my b value in this? What's half of -14? A -7. Square it, what do we get? And that is what we'd have to add on both sides. So then on the right side, that seems to be the easiest to figure out which answer goes here because they're all different on the right side. But 5 + 49 is 54. All right, but regardless, you would still factor this left side. Looking for 2 numbers that multiply to 49 but add to -14, and that's where the -7 comes from. Okay. For the next one, is it already rewritten to where the constant is alone on one side? Okay, do you see a constant on the left side that needs to move? Like a single number? Okay, what number then do you see? So 0 is already on the right side. So for this method, that's what we want. We want the single number to be alone on one side. And we want the x squared and the x term to be on the other side. So that step's already done. Then you take half of b. So what's b in this one? What is half of 2? And then we're going to square it. What's 1 squared? 1 times 1? Okay, so that's what 1 squared is, or use a calculator. But that's what we would have to add to both sides. And from that, I can tell my answer is going to be this one, because the right side ends up being 0 + 1, which is 1. But they get the left side from factoring that trinomial. What multiplies to 1 and adds to 2? 1 and 1, so that's why it's a positive 1. So process of elimination, this one's the last one. But it makes sense because when it's already rewritten to the form that we need it to be, take half of -20, square it, add it to both sides. So we would have added 100 to both sides. That's where we get the 91 on the right side. And usually this factored form ends up being this number at this stage. But I prefer that you know that it comes from you factoring versus just memorizing. You'll get confused. But yeah, it has to be -10 for the perfect square trinomial. All right, questions on this one? Questions on any others?